Okay, so let's look at the review for test 2. Notice the very first thing says that you need to know all of these library functions that are listed here. So let's just graph them real quick. You may want to put these on the note sheets that you're allowed, because you are allowed 2 pages. So the square root of x, and I'm just going to use Desmos because it will be much prettier than me attempting to draw it. So I think I can do, yep, square root of x like that. And it is that rising hill we've seen before. Now let's do the cube root of x, and I'm not sure about that. Let's see, I think if I say x to the 1/3 power, that's my cube root graph right there. So you want to put that down on your cheat sheet. Let's do the square graph. So there's your x squared, the parabola, and then your x cubed. And then, of course, the absolute value is a v. And, of course, it already assumed that I had that right side on there before I even typed it, which is nice. So you need to know those 6 functions by heart. All right, now let's go back, or at least have them on your sheet so you can call them up. And let's graph this piecewise function right here. And I'm just going to copy this part. All right, so, and I will go to another sheet because Desmos does not do piecewise functions. At least if it does, I don't know how to make it do it. All right, so I'm going to go ahead and use my draw feature as I've done in class before. Make myself my little grid. All right, now we'll start with the first one, y equals x. And let's realize this is in the form y equals mx plus b. Our m is a 1, and our b is really a 0. It's just not written. All right, now let's remember that means we go to the y-intercept of 0 first. There it is. And then we go up 1 over 1. So up 1 over 1. This graph is going to be a line going through the first and the third quadrants. Okay, but I want x values greater than or equal to 0. Here's 0. The x values that are greater than 0 are on this side, so I need to get rid of this side. Now, of course, when I erase, it's probably going to erase all of it, but I'll just draw again the side that I need, which was this side. Not that perfect, but we get the idea. Now there is an equal sign here, so I need a solid dot right here, which I already have. All right, now let's graph x squared. Let's remember x squared was one of our library functions, and it was the parabola, and it's not, of course, supposed to be as jagged and ugly as that, but when I redraw here in a minute, hopefully it will be better. We need x values less than 0. So here's 0. The x values that are less than 0 are over this way. So I need to get rid of the red part of the graph on this side. Now, of course, when I erase it, it's all going to go away. So I'll just redraw the left side only. All right, so there's the left side of my graph. Now, x is less than 0 does not have an equal sign, so there should be an open circle right here. But notice that that open circle got filled in with the closed dot. That is the black part of the graph. So really, this circle ended up being filled in just because of the other side of the graph coming in. All right, now there's our graph. But back on the review, we also wanted to find f of 4, f of 10, f of -3, and f of -5. And then we'll give the domain and range of this graph. Okay, so see if I can actually get out of this. And usually there's a button to get me out of the draw feature, and for some reason I am not getting that button. All right, well, in that case, Problem is my little controls for my video are over the top of my word controls. Let me just open another one and we'll recopy this and we'll recopy. I have to get it from the review, I guess. This. Okay, now, the thing we've got to be careful about when we're finding functional notation for a piecewise function is we've got to plug into the proper piece. So my x value for f of 4 is a 4. If I look up here, is 4 greater than 0? Well, yes, it is. So since 4 is greater than 0, I have to plug it into this piece, which means I'm just going to get a 4 when I put that in for x. All right, well, let's look at 10. Same thing, if we look here, 10 is greater than 0, so we'll plug 10 into this piece, which gives us 10. Well, let's look at negative 3. Negative 3 is not equal to 0, so this piece will not do. But if we look down here, negative 3 is less than 0. We're going to plug it into the x squared piece. We'll have negative 3 squared, which is going to give us 9. All right, and then lastly, let's do negative 5. Well, again, if we look, negative 5 is not greater than 0, so we don't want to plug it into the first piece. Negative 5 is less than 0, so let's plug it into the second piece. Negative 5 squared. Well, that's going to give us, whoops, it's going to give us 25. And there it is. Now, domain and range. I'll go back to my picture for domain and range because now that we've got the picture drawn, we can use think of our trash compactor, pushing this thing down onto the x-axis. And let's notice everything out here will get covered because that's going out forever. And everything out here will be covered. So the domain is all real numbers. So our domain, is going to be negative infinity to positive infinity. And remember, infinity symbols always have the open bracket next to them, whether they're positive or negative. All right, now our range, let's notice there's no negative y values in our graph. Our graph actually starts at 0, and we see that our pieces of the graph go up forever. So if we were to crush this thing onto the y-axis, it would start at 0 and go forever upward. So our range is going to be 0 to infinity. And 0 is a point on the graph. So it gets the square bracket. Infinity always gets the open bracket. All right, now let's look at our second one, which we may not have time to do the whole second one on this video, in which case I'll just do the second half of it on a second video. All right, so let's graph this thing. We did graph this in class, but we'll do it again so that you can always look back on it. All right, so I will take this one below this. All right, and let's graph this thing. And I'll use the draw feature, once again, to make a grid. Not a very good grid, but our first piece is y equals 2. And remember, anything where we just have y equals a number is a horizontal line. So let's draw a horizontal line going through 2. There's what it would normally look like. Hopefully yours is straighter than mine. And we need that for x values less than 0. So here's x equals 0. Less than 0 is going to be over here. So I need to get rid of the right side of this graph. All right, so of course it's going to erase all of it. But I'll just redraw the left side. All right, now there's no equal sign with my 0, so I need an open circle right there. All right, now let's graph this one down here just because it will be similar. Y equals -1 will again be a horizontal line. Now I'm going to give it a different color. So here's -1 on the y-axis. Normally, that graph would look like this, but we need x values greater than 4. So 1, 2, 3, 4. Here's 4 on the x-axis. The values greater than 4 are out here, so I need to get rid of everything to the left of 4. So I will, of course, have to erase the whole thing, and I will redraw everything that's over this way. All right, now there's no equal sign with our 4, so that's an open circle. All right, lastly, let's look at the middle piece, y equals x squared plus 1. Now we've talked about already in this video, the library function x squared is a parabola. And this is a transformation that moves that parabola up one place. So let's draw our parabola up one place. Let me change its color. So normally the parabola starts right at 0, 0. We'll have it start right here. I know my picture is pretty ugly there. All right, so there's our parabola. And I'll draw it just a little further in both directions there. Okay, now we need for our x values to be between 0 and 4. In other words, here's 0, here's 4. I only want the part of this orange graph that's between those two values. So I need to get rid of the left side. So I will, hey, what do you know? All right. And then these both have equal signs. I know my little orange covers that equal sign up a little bit, but it is an equal sign. So I need, oh no, let's undo. Here we go. Undo. There we go. All right. So I need a solid dot here and then a solid dot up here, and we've got our entire graph. All right, now I'm at 12.5 minutes, so just so that I don't run out of time, I'll go on to the next video for part B of this question.